Okay, packet 4, due Monday, April 15th. Video 4, due Sunday, April 14th. I will again set a reminder to send out and annoy you on Sunday afternoon to make sure you've got those free 100s ready to go. Let's do number 1. Researchers on a boat are investigating plankton cells in a sea. At a depth of h meters, the density of plankton cells in millions of cells per cubic meter is modeled by this thing. 0.2 h squared e to the negative 0.0025 h squared. Put my glasses on to read that thing. Okay, that looks terrible, but it's with calculator, so we can let the calculator handle the ugly stuff. That's for 0 to 30. So let's slow down here and think about what this is telling us. That's telling us the density of the plankton as a function of how deep we are. So if we plugged in h equals 0, that would tell us how dense it is at 0. If we plugged in 30, that would be how dense it is at 30. For beyond 30, so for h greater than 30, it's f of h, but we don't know what f of h is. In fact, they take the time to tell us that. F is not explicitly given. We're not telling you what it is. It's just there's some function f that describes the density when you're past 30 feet, or 30 meters, I guess. Find p prime at 25. Using correct units, interpret the meaning of p prime at 25 in the context of the problem. So p prime at 25, that's the same thing as dp dh maybe at 25. dp dh is going to help me with units more than p prime is. In fact, I'm going to just go ahead and do units right now. P is in millions of cells. This is going to be a weird unit. Per cubic meter. And then h is in meters. So our unit is millions of cells per cubic meter per meter. And you could make that per meters to the fourth, but that sort of loses the meaning of the derivative if you do it that way. Okay, so y equals 0.2 x squared e to the negative 0.0025 x squared. I don't know that the graph is really going to be that helpful to me. I know that I'm really only concerned about 0 to 30. Density will probably never be negative. I have no idea what my y scale should be. I went to 100. Looks like I could have gone to 50 for my y scale. Again, so this is how dense the plankton are. So it's like a maximum density right there, and then it starts tapering off after that. But we want the derivative at 25. So negative 1.179. Okay, but it also said interpret the meaning of that. Well, dp dh is the change in the density over the change in depth. So let's say the density is, I'm going to say decreasing since it's negative, at a rate, anytime they ask for a description of a derivative, they want the word rate. Decreasing at a rate of, and since I said decreasing, I don't need to put the negative on there. At a rate of 1.179 million cells per meter cubed per meter. I like leaving it like that because that's density over depth. If you simplify it to million cells per meter to the fourth, it's fine. You just kind of lose sight of what it means. I need to say one more thing. When or at h equals 25. So that's the rate when we're 25 meters deep. Part B. Consider a vertical column of water in this sea with horizontal cross sections, constant area 3 square meters. To the nearest million, how many plankton cells are in this column of water between 0 and 30? Okay, this is a little bit tricky for some. Here's the surface of the water. We got this column of water that's 30 meters deep. And each cross-section, we don't even know that it's a circle, but that doesn't really matter. Each cross-section is 3 square centimeters. Okay, the density is cell, I'm just going to change that to, M cells, million cells per meter cubed. So if I want the total number of cells, I need to basically multiply by this volume. I need to get 3 dimensions on there to multiply. Whoops, that should be 3 meters squared. Well, the cross-section is 3, so that'll be part of it. But I also need to add up all the way down. So what calculus thing means add them all up? The sum, which is the elongated S, also known as the antiderivative. So we're going to add up all of the P of H times 3. I'm thinking about units here. Cells per meter cubed. That's meter squared. And then dH is a meter, so that will get me back to millions of cells. That will add up all of those. That will give me the total amount in there. That one's tricky because that one you have to understand units. You got to understand what density means. I imagine that was a tricky one for a lot of people. Now the calculation is easy because the calculator's going to do it, but understanding what they've asked for. So I'm just going to do it that way. From 0 to 30, 3y1 dx. That'll tell me how many millions of cells, or millions of whatever's in there, plankton cells. 1675.415 million cells. Part C. There is a function u such that f of h is more than 0 but less than u of h beyond 30. Thank you. Oh, he's not here. So now we're past 30. If we add them all up between 30 to infinity, that's 105, although that doesn't have the 3 on there. The column of water in part B, okay, so that same column that's 3 meters squared is the area. Write an expression involving one or more integrals that gives the number of plankton cells in the entire column. So the entire column would be like 0 to infinity, 3 times the density, dH. But I have to kind of split this up because from 0 to 30, this is the one we already did, 3 times P of H dH, that gets us the first 30 meters. And then 30 to infinity gets us the rest of them. And what are we saying here? I'm trying to think, do I use F or H here? Write an expression involving one or more trig intervals that gives the number of plankton cells in the entire column. Okay, F is the number of plankton cells. U is this made-up function that equals 105. So I want F in there. Also need a 3 on there. Okay, so there's my expression involving one or more integrals. And I think the reason they said one or more is because I've written it as more, but we also just figured out what this is in the last problem was 1675. So you could write it with 1 if you filled in the number and then put the other one. Thank you. Explain why the number of plankton cells in the column is less than or equal to 2,000 million. Okay, well this one was 1675.415. I don't know what this one is, but I do know that it's less than 105 because f of h is less than u of h. So that integral in there, once I pull the 3 out, is less than 105. 1675.415 plus 105 times 3 is 315, so this is less than 315. You like this math here? Less than. So I add those together, and my answer then needs to be less than 1990.415, which is less than 2,000 million. I guess we should label that million cells. Yeah, this is a tricky one. The last piece is completely unrelated to the first couple pieces, which, I don't know, might be good news. If you didn't like the first couple pieces, you don't want anything more having to do with that. The boat is moving on the surface of the sea. At time 0, the position of the boat, xt and yt. X prime, I'm going to put this in sort of physics language for you. So Vx is 662 sine of 5t. Vy is 880 cosine of 6t. T is measured in hours. X and y are meters. Find the total distance traveled. Okay, here's the calculus part of this. Total distance traveled from 0 to 1. So what do we do to find total distance traveled? That was on something recently, I feel like. Definitely last week. What is that the integral of? So forget about this problem, just in general. How do you find the total distance? What do we integrate?
The absolute value.
The absolute value of the velocity. And I guess for this one, from 0 to 1. So displacement is integral of velocity. Distance is integral of the absolute value of velocity. So this one will always be positive. It'll always be more than the displacement. Again, running around the track, you start and stop at the same spot. Your displacement is 0, but you still ran 400 meters. The absolute value will make sure you get a nice positive answer for this one. Okay, physics people. I need an expression for the overall velocity when I have Vx and Vy. So if I have the two components, how do I get the overall? That's Vx, and that's Vy. Physics all-stars. Physics all-stars, yes? No. A squared plus b squared equals c squared. So v is the square root of vx squared plus vy squared. So this is going to be ugly, 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 but I'm going to leave it as Vx and Vy. The calculator is going to do all the hard work, so I do wonder if I should put that in. Actually, I really don't need the absolute value bars if I'm taking the square root, because that's going to give me a positive answer. Yeah, I think I'll put those in for y1 and y2. That way it's less, well, it's more typing, but I think it's easier to keep up with things. Makes my final answer cleaner if I'll put them in for y1 and y2. Make sure I'm in radians. Okay, so y1 and y2 were in there. So I want math 9, 0 to 1. I'm going to go ahead and put absolute value bars on there, even though I know I don't need them because the square root's going to be positive. Square root of y1 squared plus y2 squared dx. I wonder how long it's going to take the calculator to calculate that. That just seems like a lot to have to do. Two derivatives, square them, add them, square root them. $757.456 meters. I'm just trying to see if that makes sense. It seems like a big number. But meters traveled in 1 hour. Oh, that's not too big of a number. 700 meters is what, 7 football fields. But over the course of an hour, yeah, a boat could certainly cover that amount. Okay, maybe I should have said this at the beginning, but we're sort of near the end here. Some of these problems don't fit neatly into a previous category, and mainly that's because they cover a lot of things. Like this had some weird density thing that they just made up, and then some velocity thing from physics. So yeah, miscellaneous is the best word for that one. I'm at 17 minutes, but I spent a couple minutes at the very beginning saying stuff. We definitely slowed down to talk about things. Remember, they're supposed to be 15 minutes each, so we're in the ballpark there. Number 2. Let f be the function defined by that thing. Just note to self, we started at 18 minutes. We'll see how long it takes us. Oh, we're not doing all this one, so timing it doesn't really matter. Find the slope of the line tangent to the graph at x equals 3. Okay, so that just means find the derivative at 3. We kind of have options here. How do you want to do this problem? How do you want to take a derivative? Like, what's it going to take the derivative of this thing? What rule are we going to need? Quotient rule. There is a way around the quotient rule. If you rewrote it as all of this to the negative 1, then you could avoid the quotient rule. But I think most people are going with the quotient rule. Especially since, what's f prime? 0. G prime isn't much more difficult than that, 4x minus 7. So let's see, quotient rule is gf prime, that immediately goes away, minus fg prime, all over g squared. And so at 3 means plug in 3. So negative 3 times 12 minus 7 is 5. Oh, a safe stop coming very soon here. 2 times 9 minus 7 times 3 plus 5 squared. And there's my slope of the line tangent to the graph at x equals 3. If I was going to need that later, I would probably simplify that rather than safe stop it, but that's what they asked for, so I'm going to be done. Again, if I need it later, then I'll probably do some more evaluating and get a cleaner answer. But I'm stopping there for part A. Part B. Find the x-coordinate of each critical point. So that's f prime is 0 or undefined. Between 1 and 2.5, classify each critical point as a location of a relative min, max, or neither. So that's going to be number line, put the points on there, test the intervals, look for increasing, decreasing. But I've already got my derivative, so that makes life a little easier. So negative 12x plus 21 over 2x squared minus 7x plus 5 squared. So critical points would be where the top is 0 and where the bottom is 0. Because if the bottom is 0, that would make things undefined. So 21 over 12. That's a fine answer, but since I'm having to do more things later, I'm going to simplify it. Divided by 3, that's 7/4. And I only want numbers between 1 and 2.5. But that's a little more than 1, so that one qualifies. I hope this thing factors to make my life easier. It does factor. That was kind of them. X equals 5/2 and x equals 1. Okay. Are those on my interval? Be very, very careful. Are those on the interval? Why not? Gregory, you're right. They're not.
It's not equal.
Yeah, we don't include the 1 and the 2.5, so those are not in the interval that we're worried about. So my only critical point is 7/4. That's nice. That's a whole lot less to deal with, right? I was worried about having 3 points on the number line, which means 4 regions, which means testing a lot. Plus these are from the bottom. I don't have to worry about any of that. 7/4. And I'm going to check f prime at... I need to be careful. I don't want to check something less than 1. I can't check 1 because that would be a 0 in the bottom. So I need to check something between 1 and 7/4. Something slightly more than 1. I guess we go 5/4. I don't like that. Maybe 1.5. I don't know. On the other side, we can check 2. That would be a little easier to check. You know what? I'm maybe pressed for time. So I'm going to check the 2 and then use the alternating rule. Right? I'm going to cheat on this thing. F prime at 2. I'm looking back at my F prime. That's negative 24 plus 21 over... Now, be careful about the denominator. I mean, be careful in a good way. It's all of that squared. And all I care about is positive and negative. So what's the sign of the bottom going to be? Positive. It doesn't matter what I put in there. As long as it's not 0, I'm going to get positive. So f prime at 2 is negative. which means f is decreasing. I'm going to put both of them on there. And I'm just going to say by the alternating rule, that means this side has to be positive. F prime is positive, which means f is increasing. Okay, now what did it ask me after all that? Probably relative max and min. Okay, so what's going on at 7/4? X equals 7/4 is a relative max because f prime changes from positive to negative. So that puts a relative max there. Okay, here's part of the reason I wanted to do number 2 is that we can throw out C and D. Those are BC ideas. We don't talk about converge and diverge stuff. We can throw those out. Let's talk through the rest. Average value. I'm just looking at the questions that are asked. Number 3, average value. That's 1 over b minus a integral from a to b. That's average value. Find the volume. That's probably going to be add up all the little circles. C is related rates. So you're going to have d dt of stuff in there. That's going to be kind of tricky. Number 4, this one's kind of interesting because they start out with this formula and then they ask you questions. Well, first they just give you the derivative, so that's kind of nice. You didn't have to take it on your own. And then they ask you questions if k is 3, if k is 4, if k is, find k, and then k is 6. So that's kind of a weird one. You keep going back to that. This one is heavy on the concepts as opposed to the finding a derivative because it already found the derivative for you and it never asked for anything more than that. So they've done the hard part for you. Well, maybe not the hard part. Your job now is, well, how do I use that? So a tangent line, well, that's point and slope. Min, max, or neither. That's probably a table with f prime changing from positive to negative or negative to positive. Critical point. That's f prime equals 0 or undefined. And then partial fraction decomposition. I don't know if you remember what that is. That's where we set it up like this. And then integrate. So they'll probably both be natural logs going on there. Okay, so that's the quick walkthrough of number 4. Number 5, the derivative of a function. Okay, be careful. So I don't have to take a derivative. I mean, unless they want a second derivative. They're giving me the derivative. Told me what f of 1 is. So already I'm reminding myself that the antiderivative of f prime gives me f. And I'm using 1, so let's see what happens here. The function f has a critical point at x equals 3. Yes, because that would make f prime 0. Relative min, relative max, or neither. So that's testing on a number line. We've done that a couple times already. On what interval is the graph of f both decreasing? So that would mean f prime is negative, which we would have just found in the previous part. What is concave up? What would you be looking for there? F double prime is positive, which means you would need to take another derivative and then probably set up a number line and figure out where f double prime is positive or negative. Find the value of f of 3. Well, the antiderivative of antiderivative of f prime is the change in f. So 1 to 3, f of 3 minus f of 1. We know f of 1. We can find that. Although that would be kind of tricky. Do we know enough to find that? Do we know enough to integrate this? This part, yes. If we distributed this part, I don't think so. Would be a u substitution? Nope. So I would say let's skip C. This might have been a BC problem. Although now I'm worried because A and B were pretty straightforward. But I think to integrate that, you need some BC things. So let's throw out part C. Okay, so we did 1.5 of them together, and we kind of talk through the other 3. So that should get you going on